So welcome back. We are still on sequence and series. So we are now on quadratic sequence. So now what is this quadratic sequence? It's just simple. It's just trying to tell us that when this quadratic sequence have two common difference. This one senior man for all this sequence we are seeing. It has uh two common difference. The first one, if the first one no do you have the second one. Omo, this quadratic sequence is bad oh. So this quadratic sequence has two common difference. It's just trying to tell us the definition of this quadratic sequence is just if the second common difference is constant or remains the same throughout the whole sequence, just call it quadratic sequence. And it also has what? Nth term. As you can see it here, it has a quadratic what? Nth term. So let's read. If the second difference is constant, the sequence is known as a quadratic sequence and has a quadratic nth term. As simple as that. And you know, in your quadratic equation, x or y is equals to minus plus or minus b squared over b squared minus 4ac square root of b squared. Okay, let me write it. X is equals to, or y, anyone. Let me write y now. Y is equals to minus plus or minus square root of b squared minus 4ac all over 2f. And you know that quadratic equation must be in the form ax squared plus bx plus c, where a is not equals to 0. This thing is important. We are going to use it here. So now, example of quadratic sequence are 6, 19, 36, 38, 63, 94, 139. Now, if you look well, the common difference here, 19 minus 6, 19 minus 6 will give us 9, 13, 13. Now, let's check the common difference of this one, 38, 38 minus 19 will give us 19. Good job. So now let's check the common difference between this one. 63 minus 38 will give us 25. Now let's check this one. 94 minus 63 will give us 31. Let's check this one. 131 minus 94 will give us 37. Are you seeing something? That this common difference is not the same. You understand? They are distinct. You get? So this one is called the first common difference. First CD like this. So now let's check the second common difference. If it is not the same, we trace this thing away. It's not a quadratic sequence. Let's go. 19 minus 13 will give us 6. 25 minus 19 will give us 6. Wow. Is that so? That's 1 minus 25 will give us 6. Wonderful. 37 minus 31. Wow. So automatically this thing is a quadratic sequence. So this one is called the second common difference, which makes it to be a quadratic sequence. Now we need to know how to find the nth term of the quadratic sequence. That's nth term of a quadratic what sequence. So we need to know how to find nth term of a quadratic sequence. So the nth term of a quadratic sequence, Tn is equals to a. Instead of writing that ax squared, it will now be an squared because everything we are doing in this sequence is n. So plus b n. Instead of bx, it will be bn plus c. You get? Now, to generate the nth term of this, we are going to equate That's 2a is equals to the first common difference. 2a is equals to, sorry, the second common difference. 2a is equals to the second common difference. So you are going to equate 2a to the second common difference. Now we are going to get another one, 3a plus b. Equate it to the first. I need to write this in first second common difference so that it will not confuse you. Let me write it well. Okay, let me attach it here. First first second common difference. Okay, no need, because the common difference is the same, so no need of putting all this big grammar. Second common difference, anyone you choose, they are still the same. You understand? Now this 3a plus b, you are going to equate it to the first 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 common difference. Let me just write it, first common difference. But what I mean is this first common difference, first common what difference. That's what I meant. So now you are going to have a plus b plus c is equals to the quadratic sequence itself. The quadratic sequence itself. So let me bring it down small so that you can see. So now to find the end stem of this sequence, what shall we do? So let's write this. Tn is equals to an squared plus b. Why did I put x? Hey, sorry. Bn plus what? C. So 2a is equals to the second common difference, which is 6. So let's find the value of a. We divide by this. Our a is equals to 3. That's good. So to find this one, 3a plus b is equals to the first common difference, first common difference, which is equals to 13. So you know our a is 3, we put 3 plus b is equals to 13. 3 times 3, 9, plus b is equals to 13. Now we are going to have b is equals to 13 minus 9. So our b is 4. 9, 10, 11, 12, 13, 4. So I've gotten the value for b. Now to get this one, a plus b plus c is equals to the quadratic sequence. That's the first number in the quadratic sequence, which is what? 6. So our a is what? 3 plus 4 plus c is equals to 6. Can you see it from there? Hey, NEPA. So, wonderful. Sorry. So this will give us, this plus this will give us 7 plus c is equals to 6. So c is equals to 6 minus 7. C is equals to minus 1. I hope you can see it. So c is equals to minus 1. So let's continue from here. So it will now be a plus, okay, we have gotten the value of c. Now putting it here, so it will be Tn is equals to our a is 3, so it will be 3n squared plus our b is 4, so it will be 4n. Then our c is minus 1, so minus 1. So this is the end stem of this sequence. So that's all about quadratic sequence. Thank you for watching and may God bless you. Bye bye.